Imagine stepping back in time nearly 5 million years to a world that would be almost unrecognizable to us today. The landscapes of East Africa are transforming. Dense forests are giving way to open woodlands and grasslands. And in this changing world, our earliest ancestors are facing a critical challenge: how to survive. This is the story of life 4.8 million years ago, during the late Miocene and early Pliocene epochs. It's a time when the creatures that would eventually become humans were making crucial adaptations. Among the most important of these adaptations was diet: what they ate, how they found it, and how their dietary choices would shape the very course of human evolution. The survival diet of our earliest ancestors wasn't chosen for health or preference. It was dictated by necessity, by environmental pressures, and by the fundamental drive to survive. Understanding what these early human relatives ate gives us profound insights into who we are today and why our bodies function the way they do. To understand the diet of our early ancestors, we must first understand their world. 4.8 million years ago, Earth was in the midst of significant climatic changes. Global temperatures were cooling, and this cooling was having dramatic effects on Africa. The continent was experiencing what scientists call the Messinian salinity crisis in the Mediterranean region, though its effects rippled across Africa. More importantly, East Africa was undergoing tectonic changes. The Great Rift Valley was forming, creating new mountains and altering rainfall patterns. These changes meant that the continuous forest that had covered much of East Africa was fragmenting. Open woodlands appeared, with grassy clearings between scattered trees. This mosaic environment, part forest, part savanna, would become the crucible of human evolution. The animals of this time period would seem both familiar and alien to modern eyes. There were early elephants, though smaller than today's species. Ancient pigs rooted through the undergrowth. Early horses grazed on the expanding grasslands. And crucially, there were big cats and other predators that made every day a dangerous struggle for survival. In this world lived several species that scientists classify as hominins, members of the human family tree after our split from the ancestors of chimpanzees. The exact species alive at 4.8 million years ago is debated, but we know that creatures like Ardipithecus were living in East Africa during this general time period. These early hominins were not humans. They were not even close to modern humans in appearance or capability. They were small, perhaps 3.5 to 4 feet tall. Their brains were roughly the size of modern chimpanzees, about 300 to 400 cubic centimeters. But they possessed something that would prove crucial. They were beginning to walk upright, at least some of the time. This bipedalism, even in its early, imperfect form, would have profound implications for diet. It freed the hands for carrying food. It allowed these creatures to see over tall grass, and it changed how they moved through their environment, affecting what foods they could access. The foundation of the early hominin diet was likely similar to that of modern chimpanzees and other great apes, predominantly plant-based, with a heavy emphasis on fruits when available. Fruits were the preferred food source. They provided concentrated calories in the form of natural sugars, vitamins, minerals, and water. In the forests and woodlands of East Africa, fig trees were particularly important. Figs ripen year-round, providing a relatively reliable food source, even when other fruits are scarce. Our ancestors, 4.8 million years ago, would have been expert foragers. They would have known which trees produced fruit at which times of year. They would have understood the subtle signs that indicated fruit was ripe: changes in color, smell, and the behavior of birds and other animals that also fed on fruits. When fruits were scarce, leaves and other plant matter became crucial. Young leaves are more nutritious and easier to digest than mature ones. The tender shoots of plants, flowers, and buds all would have been consumed. This type of feeding, known as folivory, provides less energy than fruit, but is often more reliably available. The dental evidence we have from early hominins supports this diet. Their teeth show adaptations for processing both fruits and leaves. The molars are relatively large with thick enamel, useful for grinding plant matter. The canines are smaller than in many other primates, suggesting less reliance on tough fibrous plants or the use of teeth as weapons. However, a diet of fruits and leaves alone presents challenges. These foods are bulky and relatively low in calories compared to their volume. Modern great apes spend a huge portion of their day eating, sometimes 8 hours or more. Our early ancestors likely did the same, moving through their territory in search of food, from dawn to dusk. The seasonal nature of many fruits meant that our ancestors had to have extensive knowledge of their environment. They needed to know where different food sources were located and when they would be available. This likely promoted the development of spatial memory and social learning, as older, experienced individuals could pass knowledge to younger ones. One of the most important adaptations in early hominin diet may have been the exploitation of underground storage organs, roots, tubers, bulbs, and corms. This shift, though we're uncertain exactly when it began, would have been revolutionary. Underground plant parts have several advantages. They're available year-round, even during dry seasons, when fruits are scarce and above-ground vegetation has withered. They contain concentrated starches and calories, and they're relatively predictable. If you know where a plant is growing, you can return to it. However, accessing these underground resources presents challenges. They must be dug up, which requires tools or at least strong hands and nails. Many are tough and fibrous, difficult to chew and digest raw. Some contain toxins that must be processed out before they're safe to eat. We don't have direct evidence that hominins at 4.8 million years ago were eating significant amounts of underground foods. But the ecological pressures of their changing environment would have made these resources increasingly valuable. As forests gave way to more open habitats, trees bearing fruit became more scattered, but plants with underground storage organs thrived in the grasslands. The ability to exploit these resources would have required new behaviors, perhaps using sticks to dig or rocks to break open hard tubers. These simple tool-using behaviors may have been within the capabilities of early hominins. As we know, modern chimpanzees use tools in various ways. There's another crucial aspect to underground foods. They often require processing, pounding, grinding, or in later times, cooking, to make them digestible. The development of food processing techniques, however simple, represents a major cognitive leap. It shows planning, understanding of cause and effect, and the ability to delay gratification. Eating the food now versus taking time to make it more nutritious, you're safer. While early hominins were primarily plant eaters, they almost certainly supplemented their diet with animal protein when available. The easiest animal foods to obtain are insects, eggs, and small creatures that don't run away quickly. Termites were likely an important food source. In Africa today, termites are still consumed by both humans and other primates. They're highly nutritious, rich in protein and fats. Certain species swarm during the rainy season, making them easy to collect in large quantities. Modern chimpanzees are skilled at termite fishing, using sticks to extract termites from their mounds. It's entirely plausible that our ancestors 4.8 million years ago had similar capabilities. The cognitive and motor skills required are not beyond what we'd expect from these early hominins. Ants, particularly certain species, provide another source of protein. Some ants are large and relatively easy to collect. Others produce nutritious larvae that can be harvested from nests. Bird eggs would have been seasonal delicacies. When available, they provide concentrated nutrition, protein, fats, vitamins, and minerals, all in one convenient package. The challenge is finding them and reaching them, as many birds nest in trees or cliff sides. Small, slow-moving animals like lizards, frogs, and nestling birds probably rounded out the animal protein in the diet. These don't require sophisticated hunting skills, just opportunism and quick hands. The inclusion of these animal foods, even in small amounts, would have been nutritionally significant. Animal proteins contain essential amino acids in optimal ratios for primate physiology. The fats provide concentrated calories and are necessary for brain function and hormone production. However, we should be clear, these early hominins were not hunters in any modern sense. They weren't bringing down large game or even medium-sized animals regularly. The animal portion of their diet was likely opportunistic and made up a relatively small percentage of total calories. But every bit helped in the constant struggle for survival. Water is perhaps the most critical dietary requirement, and its availability shaped the lives of early hominins profoundly. In the East African environment, 4.8 million years ago, water sources were becoming less predictable as forests fragmented and climate patterns shifted. During the wet season, water was abundant, streams flowed, pools filled, and moisture was available from vegetation. But the dry season presented serious challenges. Water sources became fewer and more concentrated, forcing animals, including our ancestors, to gather around the remaining water holes. This concentration of animals at water sources had both advantages and dangers. On one hand, it might have provided opportunities to scavenge if a predator made a kill nearby. On the other hand, water sources attracted predators who knew that prey animals had to drink eventually. Early hominins likely obtained much of their water from their food, particularly from fruits. A ripe fruit can be more than 80% water. This is one reason why fruit was such a prized food source. It provided both calories and hydration. The dry season would have been the most challenging time of year. When fruits were scarce, leaves dried out, and water sources dwindled, survival became a day-to-day struggle. This is when underground tubers would have been most valuable. They retain moisture even when the surface vegetation has withered. The seasonal challenges also would have driven social behavior. Groups that cooperated, that shared information about where food and water could be found, would have had survival advantages. This may have been one of the selective pressures that favored increased social intelligence in the human lineage. Migration or nomadism within a territory would have been necessary, following the rains, traveling from areas where resources were currently available, tracking the seasonal availability of different food. All of this required cognitive mapping and planning abilities. Food in the world of early hominins wasn't just about nutrition. It was deeply tied to social dynamics. How food was obtained, who got access to it, and how it was shared all shaped social relationships. We can infer from modern primates that dominance hierarchies likely played a role in food access. Larger, stronger individuals could claim the best feeding sites or the most desirable foods. Females with infants might have had priority access in some situations, as modern chimpanzee mothers often do. But there's evidence, even in early hominins, of behaviors that went beyond simple competition. The very fact that they lived in groups suggests some level of cooperation and tolerance. Groups provide protection from predators and advantages in finding food. But they only work if members can coexist with some degree of peace. Food sharing, even in limited forms, may have been present. A large fruit, too big for one individual to consume, might be shared. Knowledge of food locations could be shared through communication and observation. Mothers certainly fed their infants, and this extended infant dependency in hominins would have been longer than in many other primates. Competition wasn't just within groups. Different groups of early hominins competing for the same resources would have been a constant reality. Encounters between groups over productive feeding sites could have been tense, though likely less violent than territorial disputes in some modern primates. The survival diet of our ancestors 4.8 million years ago laid the foundation for what we would become. Every food choice, every adaptation to new resources, every innovation in obtaining or processing food pushed our lineage in new directions. The dietary flexibility that began at these early times, the ability to eat a wide variety of foods, to adapt to seasonal changes, to exploit new resources, became a hallmark of the human lineage. As climates continued to change and environments shifted, those hominins that could adapt their diets survived and thrived. The foods our distant ancestors ate shaped our bodies in ways we still carry today. Our love of sweet fruits reflects millions of years of evolution favoring those who could find and consume calorie-rich foods. Our ability to digest starches, our large brains that eventually developed partly due to improved nutrition, our social behaviors around food, all trace back to these origins. Understanding this ancient survival diet reminds us that we are products of our evolutionary past. The foods that sustained our ancestors through countless generations shaped not just our bodies, but our behaviors, our social structures, and ultimately, our humanity. In the struggle to survive 4.8 million years ago, the seeds of human civilization were being planted.